Good evening, sir. Good evening, classmate. This is the continuation of Miss Lubayay, the first reporter. We are the group 8, and I am Maria Kristel Makawiwili, the second reporter. So my topic is all about business intelligence and business analytics. The combination of technologies such as RFID or radio frequency identification, and mobile computing described in the following section. With traditional ERP system, data is providing companies with an exponential growth in business data. While this data plays a fundamental role in the day-to-day operations of business, it also provides an opportunity for a company to perform sophisticated analysis to determine ways to improve its business. Business intelligence or BI, also referred to as business analytics, is a term used to describe a range of different applications and technologies used to extract and analyze large amounts of data to aid in decision making. BI include data mining tools and querying tools, which are often interactive and visual. So, the growth of data generating technologies such as RFID or radio frequency and identification, which diniscuss na ng naunang reporter, combined with the improvements in BI tools, has led to a significant growth in the BI market. Prior to 2008, almost all of SAP or system application and product ERP business come from traditional ERP suite applications. However, in the period from 2008 to 2011, the percentage of the business that come from BI rose to 50%. Next, this figure shows a framework for how SAP or system applications and product views or BI or business intelligence. So on the left side of the diagram are the potential BI data sources, which are growing both in number and in the volume of data produced. For example, sources such as Facebook, Twitter, and other social media applications can provide information on consumer reaction to new products. The center section represents the analytical capabilities of BI. It includes items such as analytic application and business intelligence, which are similar sets of data analysis tools, and SAP Framework analytic applications are data analysis tools applied to specific industries such as financial services, manufacturing, consumer product, retail, and utilities, or to functional areas such supply chains management, finance, human resources, IT and service, sales, and marketing. SAP BI include a set of tools for exploration, analysis, and presentation that can be applied to a wide range of business questions. Enterprise performance management is the concept of developing strategic goals for the organization and then gathering data to evaluate how organization is performing in relation to those goals. The governance risk as compliance categories represent a group of activity focused on ensuring an organization is functioning ethically and legally. Governance refer to the processes that ensure that top management is receiving accurate and timely data necessary to run the organization and that control mechanisms are in place to make sure that management directions and instructions are being carried out. Risk management consists from processes to identify risk to the organization, technological, financial, information, security, supply chains, disruption, and so on, and to develop plan to minimize the potential damage to this risk. Compliance means conforming to stated requirements, which could be consumer specification for goods or services. Sarbanes-Oxley reporting requirements discussed in Chapter 5. For the or or state and federal regulations such as the relating to product safety. Data warehousing is the technology used to store the large volumes of data used in the analysis. Enterprise information management is the relatively new term that describe the business and technology function that manage information as a corporate assets. The final sections of the diagram in figure 8 is titled Access, and it's describe how user will access BI. Previously, that was primarily through personal computers, but with the growth in mobile technology, an increasing variety of devices can now be used to access BI. Next, in memory computing, until recently, BI systems have typically accessed data that was stored on data warehouse service, which use hard disk technology to store data. Data stored in data warehouse servers usually consist of aggregated data from an ERP system or other source. To speed access to this data, the data in the data warehouse are structured as multidimensional data cubes, which allow for relationship in the data to be analyzed quickly. For example, a company might want to look at sales over time by store and by product. This means analyzing sales along 3 dimensions, and the sales data would need to be structured as a 3-dimensional cubes if the company was also interested in the need to be in looking these sales by geographic region. It would need a 4-dimensional data cubes. The two main challenges with using a multidimensional cube structure: first, a significant level of technical expertise is needed to construct a cubes, which mean that an IT specialist rather than an end user usually must complete this task. In practice, the end user and IT specialists usually have to collaborate to construct the correct multi-dimensional data cubes, and frequently they do not speak the same language. That is, the end user think in terms of business problem, while the IT specialists think in terms of database technology. Second, the multi-dimensional cube is the structures that necessarily restrict how the data can be analyzed. In the chapter 2, we introduce the topic of SAP HANA HANA in-memory computing technology. HANA allows customer to be analyzed large amount of data instantly. The key this technology is that data is stored in computer memory rather than on hard disk service. The time required to access data from memory is a small fraction of the time required to access data from the hard disk. The primary performance measure for the data storage system is latency, which is the time between with request is made for data from a storage device and when the data is delivered. Data compression is another technology that make in memory BI possible. Figure show data from an SAP ERP data table used to store material master data. This is a typical SAP or ERP table. It consists of 223 data fields, which are the column headings. As shown in figure 8, many of the fields or columns in the data table are blank or contain value of 0. By storing the data as a column rather than rows, in-memory system can reduce the size of the data by eliminating the large number of blank or 0 value by just noting their position in the table. Essentially, the system says this entire column is 0 or the next 100 items in the column are 0. When you look across the rows of the table, the number of the 0 or blank value are not as large. So the saving from noting 0 or blank values are not nearly as large. When the data compression divided by column storage, it is now feasible to store large volumes of data in memory without aggregation. This means that multidimensional large volumes of data in memory without this means that multidimensional cubes are not required. An end user can analyze BI data on the fly without needing an IT specialist to translate the data into multidimensional. SAP is not the only ERP provided with in-memory capability. In February 2012, Oracle released its in-memory solution are designed to analyze what is now being termed big data. Big data refers to the enormous amount of data that is now available for BI use from all the available sources including ERP system, website, corporate database, scientific research, Twitter, and other social networking applications. Many feel that BI and its capabilities are strategic asset to an organization that can be used to enhance future growth and viability in some experts. That's all. Thank you.